Hey everyone, and welcome back to another explainer. So today we're tackling a topic that, let's be real, you literally cannot escape hearing about right now. Yep, we're talking about artificial intelligence. But look, instead of just throwing around those same tired buzzwords, we're going to actually break down the mechanics of how this stuff operates. We're going to keep it simple, look at the structure, and really demystify the whole shebang. So, what exactly is AI? It's really easy to treat it like this magical black box where you just pour data in and boom, answers pop out. But it's definitely not magic. It's actually a very specific architectural shift in computer science. So let's pull back the curtain and see what's actually going on in there. All right, kicking things off with Section 1, Demystifying Artificial Intelligence. Okay, before we dive off the deep end into complex algorithms, let's just set our baseline here. Artificial intelligence isn't just a really fast calculator. It's an entire branch of computer science, and its main goal is creating systems that can perform tasks that usually require actual human brain power. Basically, teaching computers to think a bit more like us. We are talking about really dynamic, human-like tasks here. Things like recognizing speech, making tricky decisions, solving complex problems on the fly, and even translating languages in real time. AI systems are specifically engineered to tackle these deeply human processes. Moving on to Section 2, Narrow versus General AI. To really get a grip on where this tech actually is today, we absolutely have to separate science fact from Hollywood fiction. Basically, we have two main buckets. First, there's narrow AI, which is laser-focused on doing just one specific task really well. And then there's general AI, which is the idea of a machine possessing comprehensive human-level intelligence across the board. Now, pretty much everything you interact with right now, that's narrow AI. Your smart assistants, Siri, Alexa, they're fantastic at answering your questions, queuing up your favorite playlist, or turning off your smart lights. But, and this is key, their intelligence is heavily restricted to those very specific parameters. They aren't going to suddenly start writing a novel or inventing a new recipe on their own. General AI, on the other hand, is that ultimate sci-fi machine. It's one that can understand context, learn completely new skills from scratch, and apply knowledge across all sorts of different domains, just like you or I would. It is a wildly fascinating concept, but honestly, we're just not there yet. The entire AI ecosystem we live in today is strictly narrow. All right, Section 3, How do machines learn? So, you might be wondering, how do these hyper-focused systems get so smart in the first place? Well, the answer is machine learning. For decades, computer programming was all about super explicit, step-by-step instructions, like if X happens, do Y. But machine learning totally flips that script. Instead of hard-coding the rules, we feed the system massive amounts of data and just let it figure out the underlying patterns so we can make its own predictions. It's a total game changer. Actually, think about how a toddler learns to recognize different animals. You don't hand a 2-year-old a geometrical formula for what a cat looks like, right? No, you just show them a bunch of pictures or point out cats on the street. Over time, their brain just naturally maps out those visual patterns until they can spot a completely new cat they've never seen before. Well, machine learning essentially replicates that exact same human process, just algorithmically. Which brings us to Section 4, the power of neural networks. To actually master all those incredibly complex patterns, AI relies heavily on something called neural networks. And these are computational systems that are modeled directly, and I mean literally directly, after the biological network of neurons inside your own head. So instead of information moving in a straight, linear line, data cascades through all these interconnected layers or nodes, beautifully mimicking the neural pathways of a human brain. Because the data is being processed through these deep, complex cognitive layers, it unlocks some incredibly nuanced capabilities. When your smartphone magically groups all the photos of your dog together based on just a few pixels, or when it transcribes your voice to text in real time by predicting the sounds you're making, that is a neural network doing its thing right in the palm of your hand. Now for Section 5, AI in our daily lives. Look, it is super easy to get lost in all the algorithmic jargon, but this technology is already a massive part of our daily infrastructure. It's working behind the scenes to give you those eerily accurate, personalized streaming recommendations. It's out there enabling advanced medical diagnostics by spotting tiny anomalies in X-rays. It's helping companies make much better decisions. And yeah, it's the core brainpower making self-driving cars a reality. And finally, Section 6, the ethics of AI. Obviously, with that level of deep integration into our lives comes a frankly massive amount of responsibility. Because these models require absolute mountains of data to work, data that is very often our own personal information, we're facing some really critical global conversations right now. We absolutely have to figure out data privacy, how to secure these models from bad actors, and of course, grapple with what this all means for the future of human jobs. So, as we continue to build these incredibly powerful systems that literally mimic human thought and embed themselves deeper into our world, we're left with this one ultimate question. How do we collectively navigate the privacy, the security, and the workforce shifts to make sure the AI actually elevates humanity rather than complicates it? Honestly, it's probably the defining ethical challenge of our era. Keep asking those big, tough questions, and I'll catch you guys in our next explainer.